Hi, my name is Saeed Tahir, and I'm a member of Team BMErge, where we leveraged image processing techniques to detect intracranial hemorrhage. So we took a data set of hundreds of thousands of CT scans of the skull, and we analyzed them to see if we could develop algorithms that take certain features of these images and detect whether or not there's a hemorrhage present in them. So the problem we're addressing is that intracranial hemorrhages are very life-threatening conditions characterized by buildup of blood pressure in the skull due to the bursting of the intracranial vessels. They call it 10% of all strokes in the United States. So clinicians analyze CT scans to determine whether or not there's an intracranial hemorrhage, and then they have to classify them into 5 subclasses. This takes a lot of time, and since intracranial hemorrhage is such a time-sensitive condition, it's best for us to be able to rapidly classify these images, which is what we aim to do through our algorithms. This is important because strokes are a top 5 leading cause of death in the United States, and 10% of them are caused by intracranial hemorrhages. By having an algorithm that can quickly process these images and tell us whether or not there's a hemorrhage or not, then we can speed up this diagnosis process, which would increase patient likelihood to survive. So the data was obtained from the Kaggle RSNA intracranial hemorrhage dataset. We used 3,000 of those images, 1,000 to modify and test our code, and 2,000 to actually see whether our code has predictive value. Each image is a 512 by 512 DICOM image, shown in the bottom left. The data is stored in the CSV file right here. So the label 0 tells us that a specific type of hemorrhage does not exist, and the label 1 tells us that it does. So for this label right here, we know that there is an intraparenchymal hemorrhage and that there is some form of hemorrhage at all. So our code tests whether or not there is any form of hemorrhage that exists. And we do so through 3 separate tests. Our user or clinician will put in 1 into our program, and using 3 separate functions, we'll be able to tell you whether or not a hemorrhage exists or doesn't. We then compare this to the data from the CSV file to actually determine whether or not a hemorrhage exists and see whether or not our test has accurate predictive value. The input 2 displays a thank you message for user friendliness in the GUI. So our first function is thresholding. In this thresholding function, we filter down and denoise the image, and then we reduce it to some principal components. This region of white tells us that there's a significant region of blood. We calculate the ratio of pixels after smoothing to determine whether or not a hemorrhage exists. Edge detection does a similar thing, but this time we're finding regions of complete circles or blobs, which tell us that there's some form of blood there. So in this image, there's a hemorrhage, which we detect here in green. Protrusion is another function we use. So in the protrusion function, we detect whether or not there's brain matter outside of the skull. This is important for epidural and subdural hemorrhages. And I'm about to show you the code now. So this code run right here produces our thresholding images that we saw on the slide. And as you can see, it reduces it down to some principal components which show whether or not a hemorrhage exists. Our edge detection function right here does a similar thing. And for this image, we break it down into different components where we believe that a hemorrhage exists, or different blobs where a hemorrhage should exist. Our skull protrusion test takes a bunch of images and finds the area of brain matter it detects outside of the central skull region. And using that area, we determine whether or not there's significant skull protrusion, which indicates that there's a hemorrhage. This program right here tests through a bunch of images and produces this confusion matrix telling us how accurate our code is. And this is the behind the scenes of this code right here. So when I run this code and I input a 1, I produce a results table, which tells us for each image whether or not a hemorrhage exists. Again, our code only detects whether or not a hemorrhage exists based off of certain features of the image. This is the ID search function. It helped us look through the CSV file and helped us compile through the data and match it easier. These are our results. Our accuracy, this is our accuracy for the training, and these are our accuracies for the testing. They're lower than we hoped. This is likely because we detect specific features that belong to certain types of hemorrhage, so we can't identify all types of hemorrhages. Thank you and have a good day.